Today we will talk about the code under the hood behind Flowise and Langflow. Some of you already know how to use drag and drop features from Langflow or Flowise, and it is very powerful. But you might be curious, what is the code underneath this Dragon box? So today we will talk about the code. And before we get started, I want to let you guys know in this channel, we will constantly upload videos about large language model training, inference, and the latest publications. If you are interested in this topic, you can consider subscribe. Thank you so much for watching. Okay, let's get started. So here is the chat box we built last time for Langflow. And as we can see, we have two components. Firstly, it is the data ingestion. That's how we put the data, put the embedding into the Pinecone DB. The second part is the langchain wrapper. We combine the OpenAI, Hugging Face, and also the Pinecone DB together. And if a user has the query sent into the Pinecone, it will help us figure out the similar content. And then the content will send to OpenAI, and the on-chain flow will give the user response and the answer. So today we will go to the code to see how we can implement the same component. I would like to let you guys know that I didn't use the TypeScript or JavaScript to write or to replicate the same feature functionality, because it's very simple and straightforward if we look into their code. Here, it's pretty much how we implement the drag and drop box. So instead, I use the Python to do a demonstration. So in the code here, we also have two components. Firstly, like we said, data injection. And after that, we have the wrapper. We combine all the components together to get the user response. The constants, this is just a very basic data entry point for the variables like the Pinecone settings and the Pinecone DB, and how we set up the supported document types like TXT, PDF. So, okay, let's get into the first part. The first part is the data ingestion. As we can see, if we want to analyze the PDF file, we need to input the PDF. So here we have the PDF. We also have the PDF, the data loader, like we can see here. We basically go over the source directory and get all the files and into this document list. This is how we do the data loading. And after we have the document, we will split the document into different chunks. That's where the recursive character text splitter came in. So we have the recursive character text splitter and help us to split the document into different chunks. So after that, we will have the Hugging Face embedding. So we have the Hugging Face instruct embedding. So we have the model name, and we also have the model argument. So we don't need to put the model name, because this is the default model from the langchain. But instead, I want to make it very straightforward. So I put it here. But if you don't want to, you don't need to. And also there is the latest instructor extra large model, but it will take 4 gigabyte. I don't want to use that. This instructor large, only 1 gigabyte is good enough. So after that, you will have the Pinecone. So you need to configure the Pinecone. So firstly, we need to set up the index name. And after that, you need to the Pinecone, save the data into the Pinecone DB. Because we already set up the initialize the Pinecone here. So we don't need to do it initialize Pinecone again. So I also want to mention that the Pinecone environment or the API key you can get it from the Pinecone website. So this is how we save the embedding into the Pinecone vector DB. You don't need to use Pinecone. You can use Chroma or any other type of vector DB. So yeah, this is pretty much the first component, how we do data injection. We can run the code. What is it like? So Python injection. Yeah, it will take some time to save the embedding into the Pinecone. So yeah, let's get into the second part, is a wrapper. The wrapper, like I said, is wrap all the component together. We can see the first part is the embedding. Um, Here we also need the embedding because we also need to embed in the user input. After that, we can find the similar content from the Pinecone DB, and we can send the content to the OpenAI to get us the response. So after the embedding, you can see we also have the Pinecone DB. So here we also use the Pinecone, but now since we already have the index, we already save the data into embedding into the vector DB. We only need to get the existing index that is a Flowise from the vector DB. So this is how we consume the Pinecone vector DB. And if you want to do some analysis, for example, if you want to see how to use the what is the similar content in the Pinecone DB for your input, you can use this code to like similarity search to find the document. And also you have the OpenAI, the large language model, right? So here we know that the OpenAI model, like here is the OpenAI model, we know it. After that, you have the langchain to wrap everything together. Like I said, it's a wrapper to wrap the large language model and the vector DB together. So here is the user interact with the langchain. For example, we have the input here, and then we run the QA retrieval QA to get the answer. Yeah, we can also run this code to test it out. As we can see, we already saved the PDF data into the Pinecone DB. We can test the wrapper. Let's see, Python wrapper. Yeah, we can give some input to test our data. Okay, enter a question. Like the question we gave last time, Turing test. What is Turing test? Turing test was proposed by Alan Turing in 1955. 1955. Okay. I think it's pretty good. It's 1955. Let's get into the large language model. Large language models, what is that? Large language model. Large language, a computational model that solve complex logic. They require difficulties. Corpora. This is not that good. Let's do it one more time. Large language models are used to help their develop reduce public such as API corpora library. I think it's okay. Instruct GPT. Instruct GPT is an efficient tuning approach designed by, this is a reference, which is reinforcement learning with human feedback. Oh, this is pretty good. I think this is, yeah, this answer is very good. They even help us figure out RLHF. Okay, so we can quit this project. So as we can see, here is we save the user input into this logs. Yeah, it might be useful for in the future for us to look into. And so, okay, in this video, we demonstrate what's the code underneath Flowise or Langflow. It helps us to better understand the logic behind the drag and drop. It helps us to understand the drag and drop features. Thank you so much for watching. If you think this is helpful, please give it a like. Thank you very much. See you next time.